Hello and welcome. In this lecture, I am going to go over some examples on moment of the force about an axis. The first example that I have asks us to find the magnitude of the moment of force F about axis BC. So moment of a force about an axis, remember, it's always a scalar. It's a scalar quantity. But the problem also asks us to find a magnitude. So that's an extra hint for us that, hey, this is a scalar and not a vector. So whatever you find, it's going to be a number and not in a vector format. If you remember, moment about an axis, which here is BC, I didn't put an arrow on top because it's a scalar, equals unit vector of that axis, which again here is BC, dot producted by R cross F. So let's just kind of review what these are. So this is moment about BC equals unit vector of that axis, whatever that axis might be, which here is BC, dot producted by R cross F. F is our force, which is here given in Cartesian vector format. That position vector, that R, is what I want to go over with you. So it's a position vector. That means there is a from, start from, and there is a to. That position vector starts from any point on axis, which here is BC, to any point on line of action of force F. So let's look at it. Axis BC, any point on that axis, you can pick any point, but it's important to pick a point that you have the coordinates and you have the information. For example, B. That's my first point that I'm going to pick. So from B to anywhere on the line of action of F, which is this dotted line here. Again, I'm going to pick a point that I know the coordinates, and that will be point A. So if I find a position vector that goes from B to A, also if I find the unit vector of BC, then I can solve this problem and find the magnitude of moment about that axis. So let's see. Let's find position vector from B to A. That means you got to deduct coordinates of B minus A. B is at 0, 0, 3 meters. A is at 4, 2, 2. So it's going to be 4 minus 0, I. 2 minus 0, J. And 2 minus 3, K. Don't forget the units. 4I, 2J, 1 minus 1K meters. That's my position vector. Now let's find the unit vector BC. Unit vector of any vector, any direction, is a position vector that is in that direction and divided by its magnitude. Position vector from B going to C means you have to deduct coordinates of B from C. So B is at 0, 0, 3, C is at 0, 0, 4. So it's going to be 0 minus 0, I. 4 minus 0, J. And 0 minus 3, K. It's meters. Magnitude of it is going to be 0 squared, 4 squared, minus 3 squared, and a square root of that, which has units of meters. Meters, meters. So there's no unit for our unit vector. It's kind of ironic. And that's what we get. Remember, unit vector doesn't have unit. That unit refers to the magnitude of unit vector, which is 1. Okay. So I think we have everything that we need, and we can go ahead and solve the problem here. So moment about axis BC, I'm just going to write it in determinant format. The first row, components of unit vector BC go here. They go here. So which is 0, I. Sorry, this should have been j, because my I is 0. Yes, 0.8j minus 6k. Alright, so 0.8j minus 0.6k. I do not put ijk in my determinant because, or in my matrix, because I don't want any ijk anywhere, because remember, this is a scalar. There shouldn't be any ijk in my matrix or determinant. The second row is components of that R. So R, BA, the components go here, which I have 4, 2, minus 1. This one has units of meters. I'm going to write them right there. And last row is components of my force, which is given to me as 2I, 6J, 3. The units are kilonewtons. All right. To find this, I'm going to bring this 0 here, and it's going to be multiplied by, get rid of the row and column that 0 located at, and doesn't matter because it's 0. The second, I'm going to bring this 0.8, but you got to remember there is a negative here. Don't forget that. 0.8, and now I'm going to get rid of the column and the row that 0.8 is located at. I'm left with 4, 3, minus 1, minus 2. So it's going to be 4, 3, minus 1, minus 2. Meters, kilonewton, meters, kilonewton. Okay. Last, I'm going to bring this here, which has a negative, minus 0.6, and get rid of row and column. What I'm left with, 4, 2, 6, and minus 2. So I'm going to have 4, 6, minus 2, 2, meters, kilonewton, meters, kilonewton. If you do the math, I'm going to write it down here. It would be minus 8, minus 15.6. Both of them are kilonewton meters. It's going to be minus 23.7 kilonewton meters. So I told you that moment about an axis is a scalar quantity. The problem is asking us to find a magnitude. And we always say magnitude is always positive. So this negative indicates basically the direction that that scalar quantity is pointing. Okay? That means that component or that magnitude, instead of going from B to C, because that's where our unit vector was, it's going from C toward B. That's what this negative indicates at the end of our answer. All right, so let's move on to the next one, a little bit more complicated. Force F with a magnitude of 200 newtons is applied to the tool as shown. Find the magnitude of the moment of this force about axis X. All right. So again, I'm going to write this here for myself, moment about axis x, it's a scalar. It's going to be unit vector of x dot product r cross f. The r, I said it's from anywhere on the axis to line of action, from any point on axis to any point on line of action of f. So let's see, what points do I have? I have point O, which is located on axis x. So I'm going to start from point O, go to anywhere on line of action of f. I have the information about point A, so I'm going to go to point A. So I need to find three things here. I need to find unit vector of axis x. I need to find position vector OA, and I need to find my force. Alright, let's just start with unit vector of axis x. Unit vector of axis x is what? Remember, we use Cartesian unit vectors, which are I, j, k. Unit vector of axis x is 1i, or just I. Or if I want to write it in full vector format, is 1i plus 0j plus 0k. I write it in this form because I later need it for my matrix, and it's going to be helpful. Alright, so that one is done. Let's find unit vector that goes from point O to point A, coordinates of A minus coordinates of O. So it's going to give me O is at 0, 0, 0. Point A is located on 0i, so 0 minus 0. And the y is located at point 3, so point 3 minus 0. And z is located at 0.25 minus 0 k. This one has units, and the units for it is meters. Okay, so that one is done. All I have to do is find the force F in vector format. All I have is a magnitude. So if you remember from chapter 2, the angles that are given to me are called coordinate direction angles. Coordinate direction angles, remember, they should make that angle with positive x-axis. So alpha is angle that force makes with positive x direction, which is 120 degrees. Beta is the angle that the force makes with positive y-axis or y direction, which is 60 degrees. And gamma is the angle that force makes with positive z direction or positive z, and is 45. So if I know the three angles, my force is going to be 200 newtons multiplied by cosine 120, cosine alpha I, cosine beta, which is 60j, cosine gamma, which is 45k. The units for it is newtons, so this is going to be minus 100i plus 100j plus 141.4 k newtons. And that is my vector F. So let's put everything in a matrix format and find a determinant, and we go from there. Unit vector of x that goes into the first row is going to be 1, 0, 0. Second row, what is it? It's position vector. So it's going to be 0, 0.3, 0.25 with the units. And last row is my force, minus 100 plus 100 plus 141.4 newtons. If I want to find this determinant, I bring that 1 here, get rid of the row and column. So all I have left is 0.3, 0.25, 100, 141.4. So it's going to be 0.3, 141.4 minus 0.25, 100. These are meters, meters, Newton, Newton. So this will result in 17.4 Newton meters. This should be a scalar. And I got a number without any ijk in it. So it checks out and I should be good to go. Okay. So let's look at another one. In this one, asks us to find force of 30 newtons acts on the bracket with alpha of this much, beta of this much, and gamma of this much. Find the moment of F about the AA axis. It's very similar to the problem that we just did. We know the magnitude of the force, we know alpha, beta, gamma. Last problem asked us to find moment of the force about x-axis. This one, it's not x-axis anymore, it's just a random axis AA. Okay, so let's see. Moment about AA, I'm just going to use the same notation as the problem, equals, this is a scalar, equals unit vector of AA dot product position vector cross F. F is my force, position vector is from axis, any point on that axis, to line of action of my force F. So based on the information that I see, there's no point in that axis AA that I have the information. So I'm going to take a point that is in the same line and in the same plane as that point, and let's call that point A. Let's call this point O. So these two are in the same plane, and let's call this dotted line my ROA. Okay, and you're going to see in a minute why I picked that point O. You can pick any point that you have, but because I picked that point because Z and X coordinates of it in relation to A is given. So we're going to do this. Let's just start with unit vector of axis AA. Unit vector of axis AA. Again, we don't know any point or any coordinate on that axis. But one thing we know, which problem probably should have mentioned, but I'm just going to assume that AA is parallel to y-axis. Okay. What that means for me is that AA is the same direction as y-axis. So that solves the problem for me. All I have to do is take the position vector of AA the same way as position vector of y-axis, which is 0i, 1j, and 0k. And that's all I need. Let's do position vector OA. Okay, for position vector OA, I need to find coordinates of A and I need to find coordinates of O in relation with A. So I'm going to make a little table here, write X, Y, and Z. I put my point A to be 0, 0, 0. If I put that, then my X coordinates for axis O is given to be 100.0. That's how much I have. So it moves 100 millimeters in positive direction. So I'm going to change my units to meters here. When I look at y coordinates of O and A, I took them to be in the same plane. If A is 0, O is located at 0 also. And the last one is the z coordinates. If A is at 0, 0, then I have these two numbers to add together. And since it's going towards the negative direction, so I'm going to put 1, 5 meters. All right, that's all I need for position vector OA. All I have to do is saying 0 minus 0.1 I, 0 minus 0 j, and 15 or 0 minus 0.15 k, all in meters. Okay, so I have my unit vector, I have my r, I still need my force F, same as the problem that I just did. So it's going to be 30 newtons, cosine alpha is 60 I, cosine beta, which is 60 j, plus cosine gamma, which is 45 k. And that is my force, which is going to be 15 I plus 15 j plus 21.21 k with the units of newtons. So I think I have everything that I need. I'm going to write the determinant here in the matrix. Moment about axis AA is going to be first row unit vector of AA, which is going to be same as vector y, or sorry, axis y, 0, 1, 0. Position vector OA, the components go here, minus 1.10, 15. Did I have minus? Yes, and plus, okay? And force components are going to go here, 15, 15, 21.21. I have meters, I have Newton, no I or J or K anywhere. Because why? Because this is a scalar. I don't want any IJK to show up in my final answer. So I'm careful not to put IJK anywhere. So the first one is 0. Doesn't matter what goes into the rows and columns. The second one is negative. Remember, this is important. And I get rid of row and column that one is located. All I've left is minus 0.1, 21.21, 0.15, and 15. So it's going to be minus 0.1, 21.21, minus 0.15, 15 meters, Newton, meters, Newton. And then the last one, which is 0, doesn't matter what goes in the rest. So if you do the math on this one, you should get 4.37 with the units of Newton meters for this problem. Okay, let's look at the next problem. So the next problem says the steering wheel of the Ferrari I don't own, which is true, is shown below. If I apply a force F of this much to the wheel as shown, what is the moment of this force about the AB steering wheel column axis. So moment of this force about this axis. Okay, and it gives us the coordinates of A, B, and C, which is good. So again, moment about an axis. It's moment about what axis? A, B. It's a scalar. I'm not putting an arrow on top of it. Equals a unit vector of that axis, whatever that is, dot product by a position vector cross F. The position vector from any point on axis, which is AB, to any point on line of action of F. So let's look. Anywhere on the axis AB, well, I have both the coordinates of A and coordinates of B. So I can pick any of them that I want. I'm going to pick point A. So from A to anywhere on line of action of F. Line of action of F is that dotted line. Anywhere that I have, I know coordinates of point C. So this is going to be my position vector, A to C. So F is given. All I have to do is find unit vector of AB and position vector AC. So let's get to work. Unit vector of AB is going to be position vector AB divided by magnitude of AB. Coordinates are given. AB is B minus A. So it's minus, let me just, these are all millimeters. So let me just turn them into meters right away. Minus 0.2, we're going B to A minus 0, I, 0, 0, J, and then minus 50, minus 0. Okay, let me write the units right here so I don't forget. And the magnitude of it is going to be 0.2, 0, point, square root of all of that, which I've done the math on this. This thing is going to be 206. So the unit vector that I have is going to be minus 9.97 I minus 0.24 K. There is no units because meters. Let's do RAC, means coordinates of C minus A. A is at 0, so I'm not going to write all those 0 zeros. Point I, minus 0.19 minus or plus 0 K. This one has units. I turn it into meters. Okay. So if I do the determinant then, AB, about axis AB, the first row is going to be my unit vector, which is minus 0.970 minus 0.24. The second row is going to be my position vector, or AC components, minus 0.01 minus 0.19 and 0. And I have the units for it. And force is given in the problem statement. It's minus 12, 0, minus 3. And the units for it is given as newtons. Again, I don't need any ijk anywhere on this matrix, anywhere on this determinant, because I don't need any ijk in it. So if you do the math, you're going to get a very small number of 0.0057 Newton meters, which is probably good because when you're driving a car, you don't want this moment. Well, I'm assuming this person is going straight. because it's asked which actually steers the car, this moment that you just found. So at the moment, this car is going straight because there's not much rotation around the steering axis of the steering wheel to steer the car. So this car will probably just keep going straight. Let's look at another example. This one is a little bit more complicated because the axis that is given is just an angle for that axis is given. All right, so let's read it. Find moment of each force about z-axis. Find moment of each force about a-axis. Okay. First of all, you got to understand how things are arranged in this problem. So both point A and point B and that axis AA, they're all located in a zx plane. So there's no y component or y coordinates to any of the point A or B or that axis. So if I look at it, this is supposed to be an eye, that I'm looking at it from this angle. What I see is axis Z, axis X. What I see is axis AA, which is going within angle 45 degrees, up to this point, which is given 6 inches. And then it comes down, which I assume it's perpendicular. So this is 90. So it comes down, how much? 4 inches to get to point A. And then it keeps coming down another 3.5 inches. Should have drawn that somewhere else. So to get to point B, this is 3.5 inches. So this is how points A and B and axis A are located. So let me find coordinates of point A for you guys. A, y is 0, so it has an x, and it has y, which is 0, and it has z. Point A and point B. Okay, let's see. Let's figure out the x for both of them. For point A, I'm going to change colors here. For point A, I am trying to find this length. The first one is 6 cosine 45. The second one is 4 cosine 45. So the entire x coordinate of point A is summation of these two. So it's going to be 4 plus 6, 10 cosine 45. For point B, the coordinate that I'm looking for, 3.5 inches multiplied by cosine 45 is also added to it. This is 45, this is 45 degrees. So the coordinate of that is 6 cosine 45, 4 cosine 45, plus 3.5 cosine 45. So it's 13.5 cosine 45. Okay. So let's figure out the y component for these. Switch back. I have to redraw it again. Z, X, axis A, point A, point B, always ends up right where the X is. 90 degrees, 45, 6 inches, 4 inches, 3.5. All right, let's figure out the z component of A. This is what we want. This length here is 6 sine 45. This length here is 4 sine 45. So if I find the difference between those two, that will give me the z coordinate of point A that I'm after. And that will be 6 sine 45 minus 4 sine 45. So I just write it as 6 minus 4 sine 45. For, let's change color, green, for point B. For point B, this is what I'm after. So again, this length that I have is 6 sine 45. This length that I just found is 4 sine 45. And this length is 3.5 sine 45. So it's going to be 6 minus 4 minus 3.5 sine 45 with the y of being 0. So let's go back to our original color. Okay. So point A, I'm going to write it here. Point A is 707 inches, 0, 1.141 inch. B is 9.54 inches, 0, minus 1.6 inches. X, Y, and Z. Alright. I think that's all I want on this first page. Alright, so let's go back. Let's go to the next page. Let's see if I can get rid of this here. Okay. So the problem asks, find moment of each force about z-axis. Again, moment about an axis, moment about z-axis. So let's find F1 first. Moment about z-axis is going to be unit vector of z-axis, R cross F. R is from axis, any point from axis to any point on line of action of F. So let me look quickly. Any point on z-axis, I'm going to take just origin here, point O. On line of action of F1, I'm going to take point B. I did all that work to find coordinates of point B, so I'm going to use it. So this is going to be my R, O, B. Okay, so I'm going to take it O, B. Point, from point O to point B. Unit vector of axis Z, in the other two examples we did, how it works is just 0i, 0j, 1k. Okay. Position vector ROB. ROB is coordinates of point B minus point O, which is 0, 0, so it's 954I, 0J, minus 0.6K, all in inches. So I'm going to write those in here, 954, 0, 1.06. Force F1 is given, f1 is minus 2 plus 4 minus 8. Minus 2 plus 4 minus 8. It's going to be pounds. It's going to be inches. That one doesn't have any units. So since we are doing f1, well, if you do the math, this one is 0. This one is 0. So all I have to care about is this third one. 1. Get rid of the row and column that 1 is located. All I've left is 9.54, 0, minus 2, plus 4. So it's going to be 954, 4, minus 0, minus 2. I usually try not to put the multiple sign because we're dealing with cross product, but it's okay once in a while. So inches, pounds, and this will give you 38.16 pound inches. So I did this one. I'm going to skip the math on the rest of them. So let's do F2 about z-axis. Unit vector of z-axis dot r cross F2. I'm going to start from origin again. Axis is still the same. This time my other point on line of action of F2 is A, so I'm going to do RO to A. Okay. So let's see. Unit vector of axis Z, 0, 0, 1. RO to A, always at 0, 0, 0. So it will be 7.07 inches. I plus 0J plus 1.41 inches K. Kind of mix the units in there. So it's going to be 707, 1.41. My F2, let me look back here. 3, 2, and minus 6. 3, 2, minus 6 inches, pounds. If you do the math the same way that you did before, it's going to be 14.14 pound inch. Okay. All right, so these two are kind of easier ones because the unit vector was unit vector of z-axis. So now the problem is asking us, let me go to a new page. The problem is asking us to find moment for F1, moment about A axis. So it's going to be unit vector of A dot R cross F. R is always from axis, any point on the axis to anywhere or any point on line of action of F1. So the tricky part about this problem is finding the unit vector of axis A. Let me redraw how axis A is located. And that is going to help us find the unit vector of it. Okay. Remember, unit vector, all we care about is a direction. Right? And we know that this axis A is pointing at a 45-degree angle. I have point O. I'm just going to take a random point, O1, O2, something like that, which is located at 1 inch. All right? It doesn't matter what point you pick as long as you have 2 points on that axis. So let's see. Point O2 is located at 1 cosine 45. So I just write cosine 45. And y is 0. The z-axis is again 1 sine 45, which I just write sine 45. And my O1, which was my origin, so it's still at 0, 0, 0. there you go. You have 2 points on that axis. So unit vector of A is going to be position vector from O1 to O2, magnitude of O1 to O2. So I'm going to have cosine 45i plus 0j plus sine 45k. These are all inches. Cosine 45 squared sine 45 squared, which cosine squared plus sine squared of any angle is 1. So what I get for position vector O is cosine 45i plus 0j plus sine 45k. That is the tricky part about this problem. Otherwise, the rest is the same. Position vector from axis to line of action of F1. Look, from axis to line of action of F1. My axis, that point O is located on my axis, so I can just still use the same position vector OB and OA for each of those. So let's see. So for F1, it was OA, or OB, sorry. Position vector goes in the first row, 7, 0, 7, 0, 7.07. OB, which was 9, 54, 0, minus 1.06, minus 2, 4, minus 8. This one is inch, this one is pounds. Moment about axis, so this is for F2. Unit vector of A, R, OA, cross F2, 7.07, 7.07, OA, which was 707, 1.41. Alright, I have to apologize. These are the cosine are 0.7. So let me just correct that really quick. So we do this. Okay. So this should be 0.707, 0.707. So we're putting cosine and sine in there. Oops. Got back right here. All right, sorry about that. 707, 0.707. F2, go back to 2 minus 6. No units, inches and pounds. So the first one, if you do the math, you're going to get 3 pound inches. Wow, what happened there? And if you do the second one, you're going to get 8 pound inch as your final answer for those two.